Okay, on this problem or on this video, I'm going to show you how to solve a system of 3 equations and 3 unknowns. So you want to start by eliminating one of the variables. So if I was looking, the x's would be pretty easy to get rid of because I could multiply this one by 2 and get the x's to cancel. I could multiply it by 4. I could multiply that one by 2. Same with the 7s. I could multiply that by a -7 or a +2 and get rid of the y's. I would not want to choose this over here. I would have to get the z's to 40 or get the z's to 70 or the top and bottom to 28. So it doesn't matter if you pick the x or the y. What you want to do though is make sure that you get rid of the same variable in your first 2 steps. So I'll show you what I mean by that. So if I pick x, I'm going to get rid of, the x's, but I'm going to multiply this top equation by 2. And it's really important for you to write your steps out here and to stay organized as you're working. So these 2 equations are going to come over here, and they're going to become -2x plus 2y plus 8z equals -18. Okay, this one is going to stay the same, and I'm going to copy it. So 2x plus 7y plus 10z equals -9. I'm going to add those together, which gets rid of my x's. So now I have 9y plus 18z equals -27. Okay, now I'm going to take 2 different equations, and here's the key. Get rid of the same letter. Don't look here and say, okay, I can do this and get rid of my y's. No, you want to get rid of the same letter. So I can do these 2 and multiply my middle one by 2. I could also have done the top one and the bottom one. I'm just showing you different options here, okay? So these 2 equations are going to come down here. So this is going to, and I'm actually going to multiply by a -2 because I've got a +4. So that's going to give me -4x minus 14y minus 20z equals +18. Then this is going to stay the same. 4x minus 2y minus 7z equals 5. I'm going to add those together, which gets rid of my x's, and I'm going to have -16y minus 27z equals 23. So I have this equation and this equation that only have a y and a z in it. Okay, so now I'm going to work with them. But I'm also going to look and see if I can reduce any, all right? So if I look here, this doesn't reduce. There's nothing that goes into 16 and 27 and 23. But if I look here, I have a 9 and 18 and 27, so it can actually be reduced quite a bit. I can divide everything by 9. So it's going to become y plus 2z is equal to -3. So now that's my equation. So I'm not going to box that up. Now, you do not need to do that step. It makes your numbers easier to work with, but if you don't think about doing that, you can still work with this equation, it'll work out fine. Grab a calculator because you'll have some big numbers. Okay, now I want to put these equations together and get rid of something. Well, if I have a 1y, I'm going to work with that. So I'm going to multiply this equation by a +16. So that's going to give me 16y plus 32z equals -48. This equation is going to stay the same. So it's going to be a -16y minus 27z equals 23. So now when I add them together, the y's cancel. So I have a 5z, and 8 minus 3 is 5, and 2, and a negative. So I'm going to divide both sides by 5, and I'm going to get z equals -5. So once you have your first answer, you're in pretty good shape. The key is to not get mixed. Well, first of all, don't copy a number down wrong or make a silly arithmetic mistake, because you can see there's lots of steps here, and it's very frustrating to copy and like forget a negative in your first step. It's infuriating, so be very careful. But what I was going to say is you want to really make sure you get rid of the same letter. I got rid of the x's here, I got rid of the x's here. That is what's going to allow me to work with 2 equations and 2 unknowns to get down to 1 variable and get my answer. Now, once you have one answer, you're going to put it back up into one of the equations that has 2 variables in it. If you plug it back up here into one of the original, you've got 3 variables and you only have 1 value. That's not going to help. So take this and plug it into one of the equations with 2. I would choose this one because it's got the smallest numbers in it. So y plus 2 times z is equal to -3. So y minus 10 equals -3. Add 10 to both sides, and y equals 7. Now I have 2 answers. Now I can plug that back up into one of the equations that has all 3 letters in it. So again, I'm going to look for a simple one. So I'm going to use the original top one. And it doesn't matter which one you use. The whole point is you're trying to find the 3 numbers that work for the letters at the same time and that work in all the equations, so it doesn't matter what equation you use. So I'm going to do -x plus y, which is -5, plus, no it's not. Notice I'm using a pencil. I usually use pen to make these videos, but I'm smart because this is easy to make a mistake on, so I used a pencil. Okay, x plus y is 7, plus 4 times z, and z is -5, and that equals -9. So I use this equation and my values for z and y. So -x plus 7 minus 20 is -9. -x minus 13 is -9. -x is equal to 4 if I had 13 to both sides. So if -x is +4, then x is -4. So my ordered triple goes x, y, z. So it is -4, 7, -5. That is my ordered triple. Those are the 3 numbers that would have to go into this original equation that would work in all of them. If you plugged them in here, you get -9. If you plugged them in there, you get -9. If you plugged them in there, you would get 5.